So now we're going to move into chapter 8, where we're skipping 8.1, not because it's unuseful, but because it again makes some assumptions that I'm not the hugest fan of. And we're going to move into 8.2 instead, where we're going to look at testing differences between independent means without sigma 1 and sigma 2. That's a lot of words, but when we're talking about testing, it's still the same kind of test we did last time, just with a different sort of branching path. And we're still talking about means, just like before. We'll see what independent refers to in a little bit. And then when we're looking at without sigma 1 and sigma 2, hopefully the letter T is bouncing around in the back of your head back here after a couple chapters working with the T distribution. We'll see exactly what that looks like later. But again, what we're saying here is that we don't know information about the population that we may want. In particular, we don't know what the standard deviations are for the population, or in this case populations, that we're working with. The main change that we're seeing here going from 7 to 8 is that, thinking back to chapter 7, when we first introduced hypothesis testing, what we talked about were situations where we wanted to see if some information about a parameter held up to the scrutiny of sampling, or one sample in particular that we drew and compared it to using a Z or t-test flavored approach to see if some information still fit the pattern that we expected it to, if the parameter we had was still good and accurate and not out of date yet. Instead, what we're going to be doing here in chapter 8 is taking two parameters that have some connection or natural comparison that we can exploit and see whether one is bigger or smaller or in some way different than the other in a way we expect, or perhaps in a way that we don't, again, using samples and some flavor of Z or t-test comparison. So if we think back to that very first example that we saw in chapter 7, where we're looking at the dealer's claim about the fuel economy of some car, what we would do here instead is, rather than look at just this one car and see if the information we're supposed to know about it is actually accurate, we might take a second car and look at whether or not one is more efficient than the other, or less, or if they're just not in some way equal to each other. We're looking at that natural comparison there, and again, hopefully it makes sense in that context about why we might compare them. In your comparison shopping, as it were, you want to have some sense of how one stacks up to the other, and that's the sort of thing we're going to do here. And we'll see another quick example, a little light example as well, to keep building that connection, keep building that intuition for why we're interested in this kind of problem. So for this example, we have that sloths and koalas are known to be some of the laziest animals on the planet. A sample of 10 wild koalas were observed to be sleeping for 19.5 hours per day, with a standard deviation of 1 hour, while 10 sloths were seen to be asleep for 20.2 hours per day, with a standard deviation of 0.8 hours. And what we want to see is if the sloth, based on these samples, is the lazier animal. So for this example, the first thing we might want to do is just take down the information we have. I'm not always going to do this for every single problem, but at the very least in this case, it's useful to see that detail just to mark it down for ourselves and set some notation that we may come back to later. So we have our sloths and our koalas, where we want to make some comparison between their population mean sleep time, what we have as our samples. For the sloth, I'm going to call this X bar 1. For the koala, that'll be X bar 2. Where, again, thinking back to the sloth, we had that mean of 20.2, a standard deviation of 0.8, and a sample size of 10. It's important to note that these are sample statistics and a sample size, not population information. We're not given anything about these populations except to maybe see whether one's got a bigger mean than the other. So we're going to try to eventually get to, but this is all we have to work with. Then for the koalas, well, we had that mean of 19.5 hours with a standard deviation of 1 hour and another sample of 10, where again this is 10 koalas rather than 10 sloths. So if we want to think about this in terms of hypotheses, in terms of a test, well, we're going to say that since the 1s are for sloths and the 2s are for koalas, we might have hypotheses that look something in terms of mu1, the mean for the population sloth sleep time, as compared to mu2, the population mean for koala sleep time. And we have something else like that, because remember, we're still thinking about this in terms of a null and alternative hypothesis. We're still running a hypothesis test. It's just a hypothesis test of a comparison between two things instead of checking the veracity of one. So, when we're looking at this, what we claimed is that the sloth is lazier. And notationally, this would be the same as saying mu1, the mean sloth sleep time, is bigger than mu2. That's our claim. So, the opposite of that would be that the sloth is at most as lazy as the koala, where that, because it has an equality, is our null, and this, because it has a strict inequality, is our alternative as well as our claim. And from there we would have our other details about how we'd actually formally do this test. Don't worry too much about that now. One other way we could think about this, just briefly, thanks to the magic of algebra, which I know none of you like hearing about, but that's okay. We could instead look at this in terms of a difference. We could instead talk about these instead as mu1 minus mu2 is at most 0 or strictly bigger than 0. It has actually the exact same meaning, and in particular when we get to our next section, 8.3, we'll look more in terms of that kind of test. This is a little bit more, that's what I'm looking for, a little bit more of a natural reason to talk about it in that way there than it does here, but just know that this has essentially the same meaning. That one being smaller is the same as saying their difference is negative, or one being bigger is the same as saying their difference is positive, depending on how you arrange them. Point is, we can talk in terms of differences instead if we want to, and we'll see that more later. Just let me get a preview of it for now. Usually, though, at least for this section, that's how we're going to present these things. This is just, again, a fancy notation that says sloths are lazier than koalas. But anyway, this is just a setup. I haven't defined what the word independent means yet, and that's what we're going to be spending all of our time with in this section, so I should give you some sense of what that means, right? You'd hope so, and that's what I'll do next. So, next bit, we're going to look at what independent means, and hopefully your mind is thinking about, well, if there's independent, should there also be dependent? The answer to that question is yes, and we'll see that too in the next video.